to Educator.com. In today's lesson, we'll be discussing slope. Recall the definition of slope. The slope m of the line passing through a point x1, y1, and another point x2, y2 is given by the slope equals the change in y over the change in x. So the change in the y coordinates over the change in the x coordinates. Therefore, if you have any 2 points on a line, you can use that to find the slope. For example, imagine that you're given the graph of a line that looks like this. And you're asked to find the slope. Well, I have a point right here at x is 0. So my x1, y1 point is going to be x is 0, y is 2. I have a second point over here, and I'm going to call this x2, y2. And here, x is negative 2, y is 0. So I'm using the intercepts, but I could have used any other point on this line. Okay. An important point is that I could have assigned either one of these as, I could have said this is x1, y1, and this is x2, y2. It doesn't matter as long as you're consistent. I can't say x1, y2, x2, y1. As long as I'm consistent and I follow that consistency when I'm subtracting, I'm fine. So I arbitrarily assign this as x1, y1, this point is x2, y2. So I found 2 points in the line. Now, my y2 value is 0, and I'm going to say subtract my y1 value from that, which is 2. x2 value is negative 2. My x1 value is 0, so minus 0. So here the slope equals negative 2 over negative 2, or 1. So I could have used any 2 points in this line and found the difference between those x and y coordinates, the change in y over the change in x. So what this is telling me is that we say m equals 1, but what we really mean is m equals 1 over 1. You could think about it that way and say that for every increase in y by 1, I'm going to increase x by 1. Increase y by 1, increase x by 1. So I may be given a line and asked to find the slope, or I may directly be given a set of points and asked to find the slope. So if I were given 2 points on the line, but not given the line itself, a graph or anything, I could easily find the slope. So this is telling us the vertical change over the horizontal change. Okay. Some cases to keep in mind when you're dealing with slope is that a horizontal line has a slope of 0. And let's think about why this is so. Consider a horizontal line up here at, say, 4. Okay. So this is 4. And if I look at any point, for example, right here. Here, x is 1, y is 4. Then maybe I look over here at this point. Here, x is 3, y is still 4. Now, recall that the slope formula is the change in y over the change in x. So I have my 2 points, and I'm going to call this x1, y1, x2, y2. Again, I could have done it the other way around. All right, so I have x2, that's 4, minus x1. And then I have my x2, which is 3, minus my x1, which is 1. It actually doesn't matter what I have down here, because since I have a horizontal line, the y values everywhere here is going to equal 4. So 4 minus 4 is going to be 0. Therefore, the slope is 0. So a horizontal line has a slope of 0 because the y values are the same at every point. So the difference in y is going to be 0. Okay, vertical lines are also a special case, and they have an undefined slope. For example, let's look at a vertical line right here at x equals -3. Okay, if I look right here at, I could pick any point. I'm going to pick this point, and x is -3, y is 1. Then I'll pick another point right here. Let's say x is -3, y is -2. So I have my x1, y1, and my x2, y2. Again, slope. So my change in y over change in x. So change in y, y2, that's -2, minus 1, over change in x, -3 minus -3. This is going to give me -3 over -3 minus -3 is -3 plus 3. That's over 0. And this is not allowed. This is undefined. So we say that a vertical line has an undefined slope because since the change in x is 0, because x is the same at every point, what you end up with is a denominator that is 0, and that is undefined. That is not allowed. So for a horizontal line, the slope is 0. For a vertical line, slope is undefined. A couple of other things to keep in mind regarding slope is that a line that rises to the right, such as this one, m is a positive number. M is a positive number. So it's increasing to the right. The values are increasing. Okay? If you have a line that falls to the right, such as this one, okay, so here the slope is positive. In this case, the slope is negative. Okay? So rises to the right, slope is positive, falls to the right, slope is negative. Horizontal line has a slope of 0. A vertical line has an undefined slope. Parallel lines. Two lines are parallel if and only if they are vertical or have the same slope. Let's first check out the case where the lines are not vertical, but they are still parallel. If I have two lines that are parallel, it's going to look like this. For example, these are going to have the same slope. So if this is my line 1 and line 2, m1 will equal m2. The slopes will equal. And that's because they're changing at the same rate. These two lines are changing at the same rate, so they never intersect. Now, we set vertical lines aside. We put them separately. We don't say they have the same slope. And remember that the reason is because a vertical line has an undefined slope. So I can't say these two have the same slope because their slope is undefined. However, we recognize that they're still parallel. So we say that two lines are parallel if they are vertical, that's a separate case, or if they have the same slope. But both of these represent parallel lines. Perpendicular lines. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So perpendicular would tell me that these two lines intersect at right angles. And if this is my line 1 and line 2, and then I have a slope, m1 and m2. What this is stating is that the product of m1 and m2 is -1. Let's look at an example. Let's say I have an m1 that is equal to 4. And I say that it is perpendicular to a line L2. So this is line 1 and this is line 2, the perpendicular line. I can find this slope. I can find the slope of the perpendicular line because I know that m1 times m2 is -1, since these are perpendicular lines, and I'm given m1. So 4 times m2 equals -1. Therefore, the perpendicular line would have a slope of m2 of a negative 1/4. So the perpendicular line has a negative 1/4 as a slope, and that's the negative reciprocal of m1. Knowing that the relationship between parallel lines and the slopes of parallel lines and the slopes of perpendicular lines can be helpful in answering problems and graphing lines. And we'll see that right now with the examples. Okay, in this first example, find the slope of the line passing through the points -9, -7, and -6, -3. Well, the definition of slope is the change in y over the change in x. And I could choose to assign this either way, but I'm just going to go ahead and say this is x1, y1, and this is going to be my x2, y2. And it doesn't matter which way you assign as long as you're consistent. So I could have called this x2, y2, and it would have been fine. Would have gotten the same answer. Okay, y2 is -3, and y1 is -7, so minus -7 over x2, which is -6, minus x1, which is -9. Simplifying this is -3. A negative and a negative gives me a positive. And that gives me 4/3. So the slope of the line passing through these points is 4/3, just using my slope formula. Okay, example 2. Graph the line passing through the point -2, -1 with a slope of -2/3. Well, I'm given the slope and I'm given a point on the line. So let's start out with the point that I'm given, which is -2, -1. So that's right here. Remember that the slope is the change in y over the change in x. So if the change in y is -2, then I'm starting out here at -1. I'm going to go to -2, -3. For every 2 that y is decreased in value, x is going to increase by 3. 1, 2, 3. So I'm going to end up with this point right here. You can also say, you could have also looked at this as this. And I could say that for every 2 y is increased, x is decreased by 3. 1, 2, 3, right here. Same thing. You could look at it either way. Okay, so now I'm able to graph this line because I had a starting point right here and I had the slope. So I know that starting from here, how much the x is going to change and how much the y is going to change. So then I simply connect these lines to give my graph. And notice that this line is decreasing to the right, and that fits with what I have, which is a negative slope. So simply plot the point you're given and then use the change in y over the change in x to find additional points on the line. Okay. Graph the line passing through 1, -3, and parallel to the graph of this equation. Well, I have my point. That's 1, x is 1, y is -3. So I have my starting point. I need my slope. And I'm not directly given the slope. However, I'm given a parallel line. And recall that parallel lines have the same slope. That means that if I find the slope of this line, I'm going to have the slope of the line that I'm looking for. In order to find the slope, I need to be able to find the change in y over the change in x. So I need 2 points on this line. So the slope is y2 minus y1 over x2 minus x1. So thinking of an easy way to find a couple points on this line, I'm going to use the intercept method. And I could find these points and graph, or I could just find these points and plug them into my slope equation. So first, I'm going to let x equals 0 to find the y-intercept. Okay, so this gives me negative 3y equals 6, or y equals negative 2. Okay, so when x is 0, y is negative 2. When y is 0, let's go ahead and plug that in. 2x minus 3 times 0 equals 6. So this is 2x minus 0 equals 6. 2x equals 6. Divide both sides by 2. That gives me x equals 3. Okay, so when x is 0, y is negative 2. When x is 3, y is 0. Now I can find the slope of this line because I have this can be my x1, this can be my y1, this can be my x2, this can be my y2. So let me find the slope. This is y2, which is 0, minus y1, negative 2. This is x2, which is 3, minus 0. That's x1. This is going to give me 0 minus negative 2, so 0 plus 2, over 3 minus 0. So the slope is 2/3. Therefore, the slope of this line is 2/3. And since parallel lines have the same slope, the slope of the line I'm looking for is also 2/3. Now, I was given this point, 1, negative 3. Now I know that the vertical change is going to be an increase in y by 2, and there's going to be a change in x, an increase in 3 by 3. 1, 2, 3. So I have another point. So now that I have this second point, I can go ahead and graph this line. And this is the line I was asked to graph, so I've completed what I've been asked to do. But just to look at the idea that this is indeed a parallel line, I'm going to go ahead and plot this other line as well. So this is the line we're asked to find. This other line, when x is 0, y is negative 2. When x is 3, y is 0. And you can plot that out and see that visually this does look like a parallel line. And these two are changing at the same rate. The slope of both of these is 2/3. Okay, so I was able to graph the line passing through this point and parallel to the graph of this line by finding the slope of this line and then realizing that my parallel line is going to have the same slope, which is 2/3. Example 4. Graph the line passing through the point negative 2, 1 and perpendicular to the graph of this line. 3x, the graph of this equation. 3x plus 4y equals 12. Okay, I've given a point, and let's see. Let's call this negative 2, negative 4, negative 6, negative 2, negative 4, negative 6, 2, 4, 6, 8. Okay. Negative 2 would be right here, and then 1 would be right about there. So that's my point. But I also need the slope. Recall that the slopes of perpendicular lines, the product of those slopes is equal to negative 1. So the product of perpendicular lines, M1 and M2, I have two perpendicular lines. The slope of one is M1, the other is M2. Their product is negative 1. So I'm going to call this first line, line 1, and its slope is going to be M1. So I'm going to find M1. My line I'm going to call line 2, and its slope is going to be M2. So I need to find the slope of this line. Recalling that slope is the change in y over the change in x. So in order to find this change, I need to find 2 points on this line. I'm going to go for something easy. So I'm going to let x equal 0, and I'm going to plug that in here. I'm just going to find the intercepts as my 2 points. But I could have found any 2 points on that line to get the slope. Okay, so this is going to give me y equals 3. When x is 0, y is 3. For my second point, I'm going to let y equal 0. So that's 3x plus 4 times 0 equals 12. So if 3x equals 12, x equals 4. So now I have 2 points. 2 points means I can find the slope. So I'm going to say that this is my x1, y1, x2, y2. So I can keep track of everything. y2 is 0. y1 is 3. So 0 minus 3 over x2, which is 4, minus 0. Okay, I've found M1. I've found the slope of this line. And I know that the line I'm looking for, which is going to have a slope M2, is perpendicular to this line. So I'm going to go right here and say that M1, I know that's equal to negative 3/4. And I'm looking for M2. M1 times M2 equals negative 1. So now all I have to do is substitute this in, negative 3/4 times M2 equals negative 1. I'm going to multiply both sides by negative 4/3 to move this over to the right. And that's going to give me negative 1 times negative 4/3, or M2 equals 4/3. Okay, now I found this slope, and I need to graph the line. I have my starting point here at negative 2, 1, and the change in y is going to be 4, so that's going to be 1, 2, 3, 4, for an increase in x of 3. So that's 1, 2, 3, right there. Increase in y by 4, 1, 2, 3, 4, increase x by 3. 1, 2, 3. So right about there. Okay, so I can go ahead and plot this line out. Reviewing what we did, we were given a point that the line passes through, and we needed the slope in order to graph it. We were told that this line is perpendicular to the line described by this equation. Therefore, we found the slope of this line, and we did that by finding 2 points in the line, actually the x and y intercepts, and plugging that into the slope formula. Once I found the slope of this perpendicular line, I wanted to find the slope of my line, and I did that by recalling that the product of the slopes of perpendicular lines equals negative 1. So negative 3/4 times the slope of the perpendicular line is negative 1. I figured out that the line I'm looking for has a slope of 4/3, and then I just took my point that I was given and increased y by 4 and then x by 3. That concludes this lecture about slope on educator.com.